Hey there, welcome to my news channel. So I'm going to go through an article which was black holes, well, specifically supermassive black holes, are rarer than we actually thought. There's always a question on how do these supermassive black holes come about. They're different from the common type of black holes you commonly hear about. Very different. I mean, these ones are crazy big. You can see over here they got jets coming out of it, and I'll go through that. They're way more cooler than a typical normal black hole. So I'm going to go through these active supermassive black holes. So in the article, it starts off by telling us the common that every single, especially a large galaxy has a black hole in the center. Well, specifically, they have a supermassive black hole in the center, which is very different from a common black hole, because a common black hole has a mass of around about 3 suns. Supermassive black holes, the one in our Milky Way galaxy, has a mass of around about 4 million suns. Some of them go up to tens of billions. I believe the biggest is around about 70 or 80 billion mass of stars. So these get incredibly big, and the whole formation of them is what is the mystery behind everything. Now, not all of these supermassive black holes are active. Some of them are sleeping, but when they are active, we give it a particular name, an active galactic nucleus, which give out these charged particles which you see over here. Now, these sometimes are active because maybe two galaxies are merging. There could be different things. Maybe some mass is going inside that supermassive black hole, so it's going to be, things are going to be swerving around it. It's going to be very, very active, and some of these get so bright they're even brighter than their galaxy. So imagine this, okay, in your center you're brighter than the whole galaxy combined. This is why there are some theories that we can maybe harness the energy given out by a supermassive black hole. So these jets of gases, jets of particles, they go outwards. They're kind of like a recycling center, because when things go in, these just push it outwards, and those charged particles go elsewhere, and they are used to make stars, planets, and so forth. So it's kind of like a recycling center, if anything. But there are theories that we could maybe capture the energy that comes out of them, rather than just let it go out into space. Now, they use the James Webb Space Telescope for this, which is much more precise than the common Spitzer. So if I show you a picture over here, this is the James Webb Telescope, okay, and the Spitzer is this one over there, and the James Webb is much better. The Spitzer relies more on infrared radiation, and James Webb is more precise. I wouldn't say precise, but it's more sensitive, so it could pick up other things that the Spitzer wouldn't be able to pick up on. Now, what they did is they used the James Webb to focus on a specific strip of sky that was interesting, that's something that was picked up before with the Spitzer, but we couldn't go too much into detail. So instead, we use the James Webb. We know where that strip of sky is, and they focused on it. And it was believed to be star formations from around about 10 billion years ago. So this must be many light years away, around about 10 billion light years away, and we're picking up on that radiation, so we could see the formation of what was going on around about 10 billion years ago, which kind of gives us the mystery of the formation of the universe. Now, what was interesting is they observed with the James Webb, they observed 500 galaxies, and they only found that 6% of them actually had an active nucleus inside them. So this kind of makes a question, because we were expecting much more of them. So it's kind of like giving us a question: how these are formed, why are so many of them not active? It gives us a lot of questions to ask about this, because supermassive black holes play a role in the evolution of our galaxies. Like I told you before, they're kind of like recycling centers, so what we want to do, we want to understand this better, because without an active one, you're not going to be forming, for example, stars and planets elsewhere. You need an active, gigantic one in the center to get the stuff in, push it away many light years away, and it's makes the galaxy more uniform rather than it just being in the center, if that makes sense. Now, there are some theories that some active black holes are just hiding, and we maybe need more sensitive equipment just to detect these. Another theory is they go through periods of being active, not active, active, and so forth. Now, they are going to do a bigger sample size, so they are going to try and look at maybe 4,000 instead of the 500 they looked in. If you enjoyed this video, please subscribe and give it a like. Take care. Have a nice day.